Well, hi, good morning. Thanks so much for joining me here in my shop. I'm just getting ready to start on the radio, and the first thing I'm going to do today is repair this gargantuan tear through the speaker here, which you saw in the last video. You could actually see it flapping in the wind. So we don't want that anymore. I want to try to make sure there's no problem or distortion coming from the speaker before we go further, and going further means changing a bunch of old capacitors underneath the radio, even though it's working surprisingly well at this point. So that's my next goal. A little bit of glue and a little bit of paper and that'll be fixed. So I'm just mixing up a little bit of water and ordinary white glue here, nothing special about it. White wood glue. I want this fairly thin. I'm going to soak it into some paper. Okay. And what kind of paper? I like to use, because I'm very, very cheap. I like to use paper towel here. Grab a little bit of paper towel. I need a fairly large piece here. Let's just check it against the speaker. Well, that's way too big. That should do it. Okay, I'll throw it back in the glue now. Ooh, that looks pretty thick. I think that's too thick. Bring a little more water into it here. Actually, you know what? That isn't very thick. Okay, we soak in the paper. Swoosh! Wow. Now I gotta take that flimsy piece of paper and just stick it on the speaker. Too much glue on it. That's a big repair patch. Oh, for crying out loud. Yeah, the thing about glue is it's sticky. Okay, now I'm going to work it nice and flat here. What we're trying to do is seal the holes. And up here, we don't want things to stiffen up too much, so it's going to be hard to prevent it. Oh, just look at my face. I grabbed the gluey end of the stick. It's going to stiffen up nicely. Now there's another little hole right there. There we go. Stick a little tiny bit of paper. Oh my god, my fingers are just completely glued. Okay, any more holes? Is that a hole right there? It's a weak spot. That looks pretty good. Looks like the cone is tearing away up in here. Ooh, I've never really looked for right up in the edge there before. The rest of it looks good. Just right in here. I think I'm going to leave that just as it is though. So the part of the speaker that's moving the most, of course, is down here. And as you move out, it's less and less movement until you get to the outside where it's fixed in place. So by the time you get right out on this outer edge, there shouldn't be any flex movement going on. So whatever has happened here, it's probably been like that since pretty much day one. I'm not sure what I can do to... You know what I can do? Stick some of this glue in there, why not? Maybe that'll freeze it up a little bit. I may be worrying about nothing there. Okay, so we gotta let this sit now for a while and dry up, and then we'll carry on. I have to go get the glue off my fingers. Now there's glue on my computer mouse. Okay, so I've let some time go by. Let's see if this is dry now. It doesn't look particularly dry. Oh, I think it's ready to go. Good. Okay, next, what are we doing next on this? I think the next thing, you can change out the capacitors on the audio side of the radio. So what we're talking about are these ones here. Output tube is there. That's right, I was considering this resistor first. Let's think about that. So if I remove this resistor, and because there's a 50L6 in here instead of a 35, and then 10 years from now, this radio is in it will be in somebody else's hands. This isn't my radio. And that person's going to say, hey, look, let's put a 35 in here, 35L6. And without that resistor, he's going to be in trouble. So maybe the name of the game is, if this thing will work good enough with that resistor in there, I should just leave it. Leave it as is. I think that's the decision. Now, as for the capacitors here, so you can see this one conveys the audio from the volume control. I guess this one is conveying audio from the detector tube to the output tube. These ones, I'm not so sure about what they're doing offhand. I'm just going to change all four of those out. Because the radio's working fairly well, I wouldn't expect much of a change in the radio's operation, so I'm not going to check that. I'm just going to go ahead and change those four capacitors there. So I think what I'll do is on video I'll remove each capacitor one at a time and test them, and then I'll put the replacement in and then do the next capacitor and we'll test them. So you'll see the test of each capacitor as they come out. And I'm really good at forgetting where parts come from the moment I look away. So I'm going to put a clip lead on there so I can't forget. The other end of this one here, I'll just leave a big chunk of wire here hanging there. Okay, let's take this one over and we will give it a test. Just gotta find my test leads. Here they are. So the test we're doing here is we're going to apply some voltage across the capacitor and see if any current leaks through the capacitor. The leaking current will cause this magic eye to close, or stay closed is the way I should put it. So I'm going to flip this on. It'll apply 50 volts to the capacitor. For a moment the eye will close and then it will open as the capacitor charges. If it doesn't open, it's because the capacitor is leaking. 50 volts. Here we go. Oh, that just opened up like new. didn't quite open all the way on 150 volts. This is a 600 volt capacitor. Let's give it another shot. So, you know, as capacitors go in old radios, you can see this opened just a tiny amount. This is by far not the worst capacitor. Let's look at its condition here. And we'll look at it with a close-up camera. Why is this capacitor still in fairly good operating condition? So it looks nice and uniform all across its surface. Okay, there's no a little better focus. There's no wax dripping off the end. When you look at the ends, the wax is uniform, tight up to the where the wire goes in. Same thing on this end. So this looks the way it looked when it was new pretty well. And that's probably why it's in good shape. It has not absorbed too much moisture. Now, I mean, that has an awful lot to do with the life of the radio and where it's been and what it's been doing. 0.01. So I'll put a 0.01 in there, then we'll pick the next one to do. Okay, let's solder that up. Now I had to start replacing another capacitor because they're sharing this terminal. There we go. Very good. Now, to the other end of this one here. I'm letting autofocus operate my camera right now. I don't think this is really going to grip the terminal very much, but if I can get it to lay up nice and tight to it. Whoops, that didn't work. That's good enough to solder like that. Now it may just pop off as soon as I melt this. We'll see. No, that's got it good. Okay, so that's two capacitors in. There's this one here. Two more to go. It's this guy right here. Oh, I was going to test. Well, let's not get confused. Let's not get confused. I've got these two to test. Let's test them. Let's give them a test here. I already tested this one. So this is a molded capacitor. Inside, I think it's pretty much paper and wax. But then it has a molded plastic shell, which the thinking was would be much better. Turns out, not much better. 50 volts to start. What will the eye do? Pop right open. 150, pop right open. And what is the rating on this? 400 volts. So that's capacitor is testing really very good. Let's measure its capacitance. 0.025 is what it's supposed to be. 0.025 is what will be on this scale. And just watch for the eye to pop open again. Right here. Now we read that. Get on the right scale here. The one that ends in 0.5, 0.1, 0.05, 0.02, 0.025 would be right here. And look where it is. It's right near there. So, perfectly good capacitor. Should I stop? Should I stop? That's a good question. Well, not with this. I should get rid of this one. But maybe changing the rest of these out is not worth it. It's just not worth it. That's the impression at this point. Okay, let's do the next capacitor. I'll just keep the video rolling here. Go off here. Okay. 0.01, I'm pretty sure that says 0.01 there. Let's give them a test right away. Find out what's up here. Okay. 50 volts, what do you do? Opens right up. Not so good at 150. So a little worse than the, qualitatively a little worse than this one. But as capacitors go, old capacitors and old radios go, not the worst, for sure, not the worst. So I'm going to stick one of these big ceramic guys in there, which I have many. And just checking that last capacitor, it was a 0.01 for sure. Yep. So I'm going to put a 0.01 right in there. Don't need much leads. These particular capacitors have gargantuan leads on them. Okay. This morning when I turned on my TV, I discovered quickly that the American channels are not coming in. If you're American, you may or may not realize this, but up here in Canada we get all the American channels from our cable company, depending upon the package that you order. But Canadian TV is essentially identical to American TV. Plus we have all the Canadian channels too, which I don't think Americans get on their TV. I'm going to assume that that's the case. They don't get Canadian TV. Maybe I'm wrong about that. But in any case, no American TV stations on the cable system this morning. This has happened before. I imagine it's something to do with some international feed that comes across from the States. I don't know. Don't know how it all works. So I didn't get a chance to check up on what was being said on CNN this morning. Set up a short circuit right here, like this. Straighten this thing out. There we go. Okay. Yeah, when I whisper like that, you're not supposed to hear it. That's just for me. Uh-oh, everything's coming off. Doesn't look very good there. Feels pretty solid. Yeah, I think it's solid. Okay, I'll leave that. I'm monkey with it. Okay, now I was thinking of leaving all these other capacitors in here. While I do like the idea of leaving things as original as possible, goodness knows these capacitors won't last forever, but then none of them will, even the ones I'm putting in. Why don't we test the radio at this point? Let's test it, make sure it's still working. Get to hear the speaker too. See how the whole thing works out. I just about shoved my fingers through that speaker. Wow, that was close. That was close. Okay, so that's dried up pretty good. Switch is off. Power is on. I'm going to watch those dim lights. This one. In case I boop something up bad. I think I'll switch on with the control panel. So on here. Here we go. Nothing scary happening. The tube's lighting up. But time. Ooh, that scared me. But time to change this light bulb so I know for sure when the radio's on. Okay, man, what are you doing? Well, it's not supposed to do that. What darn fool thing did I do now? Oh my gosh. Really? I gotta stop talking while I do this work. Let's put it up like this. What dumb thing has happened here? It sounded like I connected it right to a heater. That's what it sounded like. Okay, did I work a short circuit in here? Doesn't look like it. No. I soldered this one. Okay, this guy. Nobody's touching anything. It comes over here. Uh-oh. Uh-oh, something's happened and goodness knows I don't know what. What stupid thing did I do? It has to be something stupid. Looking everything over really carefully. Did I disconnect something? Like, was there a bridge maybe between here and here, and it fell off when I was soldering? I don't think so. I don't think that happened. Oh my gosh! I'm just looking everything over really carefully. Maybe a short, and maybe this shorted. Maybe this resistor here. The lead is tucked up real tight. Doesn't look like it. No, I can't say that's shorted. Oh my gosh, what happened? Big hum like that. Big hum like that. It's like, you know, somehow I accidentally connected to the heater line or something. So if we follow this yellow wire from the back of the switch, it travels right to here, where it picks up one of these capacitors I put in. Which then comes over right to the volume control. Isn't that a little strange? Is that a little strange? The capacitor, wait a minute. There's also this wire. This wire's heading for the light bulb. So, so this is the heater. This heading to the light bulb. One of these are both heading to the light bulb. One of the two of these is hooked up. Is hooked up to a center tap in the heater. You'd have to guess it's this one. Look, there's a jumper wire coming around here to here. What's that doing? What's going on there? So this is definitely the 35Z5. 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 Pin 2 is a heater. why is our capacitor going to here? So the center tap is pin 3. That's pin 3. So this is the center tap, and the center tap has a jumper going over to, and that's going to be pin 1, 2, 3, 4, 5 over to pin 5. Okay, so 5. Oh, 5 is the plate. What is happening here? 1, 2, 3, 4, 5. 5 on 35Z5. 5 is the plate. Oh, that's right. Yeah. Some of these radios, they run the plate currents through the light bulb. Maybe that's what this is kind of. Yeah, I don't get it. I gotta look at the schematic to sort this out. Yeah, I don't know what's happening. What's happening? How could I have made a mistake? The capacitor was there previously. Let's sort this out on the schematic. I think it's the only way. Okay, well, I think I did find my goofy mistake here. So this yellow capacitor, this guy here, this side's fine, which you can't see. This side here is fine. The other side, oops, I made a boo-boo. So it's connected to this terminal, and it really should be connected to this terminal. This terminal is a B- point. Any B- point would do. I just stopped short. So in effect, what I did was I hooked up a capacitor from the heater of the rectifier tube to the grid of the detector triode. Hey, that should cause a hum. Oh, what am I doing? Automatic focus. So I just got to move this over. It's a stupid mistake. I basically pile drived an AC signal right into the grid of that tube. Now, how am I going to get there? The capacitor lead's not long enough anymore. Any ground will do. Any ground, any B- point will do. Where's there another B- point over here? Tell me they all end here. My wire's just not going to make it. Find another point. Find another point. Extend the wire a touch. You know what? I think this is a B- point here too. It is. This one here. Yeah. Okay. Swing it over there. Swing it over. Yeah. Well, unhook it first. Just gonna cut it free. Hope I got enough wire now. Swing it over here. Put it up there. Lovely. Okay. So I don't know about other people, but my error rate while doing this work is embarrassingly high. It seems to me that I just managed to make a lot of mistakes when I'm doing this stuff. Am I making another one right now? Sometimes it seems the harder I try to not make a mistake, the more likely I am to do just that. Let's see if we can squeeze that a little bit. That'll do. A little bit of solder. So my teachers used to comment on my early report cards that I spent too much time daydreaming. Daydreaming? They were just seeing creativity, weren't they? Maybe their lessons were too boring. think that's going to stick. I don't think the solder's traveling here. Oh, maybe. Oh, that's pretty solid. Yeah, that's solid. Okay, here's a chance now to see. Did I fix my mistake? Did I introduce a new one? Yeah, I'd say a good 20% of my time in the shop is identifying and correcting my own errors. Something like that. Maybe not 20. Maybe not 20, maybe 30. Okay, switches on. Power on. Dim bulb good. All is good. Let's put the dangerous solder away. Here we go. Okay, no crazy hum. Any sound? Okay, let's tune something in here. Soldering iron puts a lot of distortion. Now, if the radio's working good, we're going to pick up a French station at 860. There's a voice there. Can you hear it? I can hear it. Whoops. So I'm going to bring up the antenna booster here, and I'm going to have to go throw a switch. So all this is just a loop connected to an outdoor antenna, basically. I won't go into it in more detail. I gotta go throw a switch to turn it on, though. We'll get a little better antenna boosting here. Whoops. Hey, I see CNN is back on the TV, so our cable's back to normal here. Just in my little part of Canada. Now we'll tune this. Doesn't tune very well. Well, I won't worry about that. Yeah, I don't know. Good enough though, we can hear it. Good enough, good enough, good enough. That's not too bad. I think what's next now, on the radio before going any further is to do an alignment and really see how well this radio can perform, even with its older molded capacitors still in there. I'm inclined to leave them at this point. Great. Okay, well that's it for today. Thanks a lot for watching, and probably tomorrow we'll finish this guy right off.